So today we're going to be talking about exponent rules and just exponents in general. So in introduction, we're going to be talking about what are exponents. We're going to be talking about multiplying and dividing exponents and exponents with exponents. And then lastly, we're going to be talking about the power to zero. So what are exponents? Well, these are essentially just repeated multiplication. It's a lot easier to understand what exponents are with an example. So you're going to have a base of 3 and an exponent of 4. So if we see repeated multiplication here, 3 times 3 times 3 times 3, we're going to have a base of 3, but to the exponent of 4, represented by this little symbol here. Essentially, this just means that 3 would multiply itself 4 times in total to get the answer. What is really important here to make sure that you don't mess up exponents and find out the solution correctly is BEDMAS. Although you're already familiar with most of it. So I'm just going to draw your attention to brackets and exponents, and just keep in mind that brackets come first before exponents. So with that in mind, we're going to have some examples. So let's say we have 6 to the power of 4. It's essentially what we did before. We're going to have 6 times 6 times 6 times 6, in total 4 times. In total, we're just going to get 1,296. And let's see here with some variables, as this will be important when you talk about linear equations and maybe quadratic equations and the such. So here we're going to have a and b to the power of 5. And it's important to note that since we have two types of actions going on here, we have multiplication between a and b. But firstly, we have b to the exponent of 5. So since this comes first, we have a times b times b times b times b times b. And here is when the BEDMAS rules are really important. We have both brackets and exponents. However, because we know better, we're not going to do a times b, like 3 b's. We're actually going to have a, b in brackets times multiplying itself 3 times. And if we just simplify this, at the end we get a to the power of 3 times b to the power of 3. So now we have a situation that's a little bit harder. We have in brackets a plus b instead of a times b. And essentially just the same scenario. How we just get this time? A to the power of 3 plus 3, a to the power of 2 times b plus 3 times b to the power of 2 times a plus 3b to the power of 3. So this is just trying to emphasize the importance of knowing BEDMAS and brackets coming before exponents. So now we're going to be multiplying, dividing, and exponents with exponents and talking about how these work. So essentially, when multiplying the same bases with exponents, we would just add the exponents. So just starting off with 6 times 6 equals 36, which is essentially 6 to the power of 2, you can see that these 6's have a base of 6 with an exponent of 1 each. And if we were to add up these exponents, which is an invisible 1 here and an invisible 1 here, we get 6 to the power of 2. However, much more visible, we see that 6 to the power of 3 times 6 to the power of 2 isn't going to be 36 this time. We can see that if we expand this, we have 6 times 6 times 6, which is the first one, times 6 times 6, which is the second one, we have 6 to the power of 5, which is 3 plus 2. This is also the same scenario when dividing bases, but now we're going to be subtracting the exponents. As you can see here, 6 to the power 3 divided by 6 to the power 2 is going to become 6 times 6 times 6 divided by 6 times 6, which we know is that when 2 of these 6's cancel out each, we're going to be left with 6, or 6 to the power 1, which is 3 minus 2. However, when we have an exponent 2 and an exponent, would be multiplying the numbers. An example is going to be 6 to the power 2 in brackets, as we know that brackets come first, all of that to the power 2. So if we were to expand that, we're going to get 6 times 6 in brackets times 6 times 6. So because it's just multiplication now, we can let go of the brackets, and we know that it's going to be 6 to the power of 4. And as 4 is 2 times 2. We're going to be talking about the power of 0 and how exponents just essentially work. What is important to know is that negative exponents create reciprocals of the base, which is just if we have 6 to the power of negative 2 as opposed to 6 to the power of 2, we're going to get 1 over 6, which is first reciprocate the base. And then we have to the power of 2 as opposed to just 6 times 6. Over here we have 1 over 36. While here we just have 36, and we can see that negative exponents just reciprocate its positive counterparts. So how do we really find these, and what is this mysterious 6 to the power of 0? So just a hint on how exponents work. When we would just be dividing or multiplying the base based on the exponent. For example, if 6 to the power of 1 was just 6, which was just 1 of 6, that means that 6 to the power of 0 would just be dividing the base by itself by 1, which would mean it would become 6 divided by 6 equals 1. However, you can see that this is why we would create reciprocals of the base. Because if we move towards 6 to the power of negative 1, we would get 1 over 6, which would just become another division of this base, which is 1, and we would divide 1 by 6. Therefore, following this pattern, it doesn't matter what the base is, all numbers to the power of 0 is 1. And that's just a thought to keep in mind.